So we come now to the next part of our discussion, which is all about the techniques of integration. So in our previous discussions, we have learned about some integration formulas in which we just directly apply to a certain integral. But this is not the case in all integrals. There are some integrals that cannot be evaluated directly from the formulas we have discussed. So there need to be some transformation for those integrals to be evaluated. So those transformations and techniques will be discussed in this chapter. The first technique that we will be discussing is the integration by parts. So if you recall in our previous discussions, the integration formulas were fundamentally derived from reversing the differentiation formulas. So from a differentiation formulas, we just reverse the procedure, or we just get the antiderivative, then we get its corresponding, or we get its corresponding integration formula. Now, for integration by parts, this is actually taken from or derived from the product rule. So if you recall, if we have two functions, if we let u and v be functions of x, and we have the product of these two functions, u times v, if we get the derivative of this product, the result is just you copy the first um, function times the derivative of the second function plus the second function times the derivative of the first function. Okay, so the derivative of a product is equal to this. Now, if we apply antiderivative to both sides of the equation, then we'll have this. Of course, ito siya will just be cancelled out. Then we'll have uv is equal to the integral of u dv plus integral of v du. So from here, if we rearrange this, we could say that the integral of u dv is just equal to uv minus the integral of v du. So this is now the formula of the integration by parts. So it is called integration by parts because we are looking at the integral as containing two parts or two functions. We have the function and the derivative of another function, which is may or not be related to the first function. So let's have an example for this. Okay, let's take a look at this first example, our first problem. We have to evaluate I is equal to the integral of x exponential x dx. So in this problem, we don't have a formula that would directly solve this integral. But we could say that this particular integral contains two functions that are not really related to each other. What I mean is that the derivative of this function does not yield a linear function in the form of x dx. Same as this does not yield an exponential function. So one technique of solving this is through integration by parts. Now, basically, for starters, integration by parts could require some sort of trial and error, diba? Because you need to identify which part of the integral will be the first function u and which part would be the other function v. Okay, to solve this, we will try to look at this integral in the form of integral of u dv. Okay, so we will look at this integral na dalawa siyang function u and v. So that would now be more on trial and error na. Which part will be u and which part will be dv. So, ganito ang gawin natin by trial and error. Example, sabihin muna natin yung u as exponential x, and syempre yung dv natin, again, yung hinahanap natin is yung u dv, or we are trying to look at this as u dv. So kung ang u natin is exponential x and dv natin is x dx, so ito x dx, then it follows that the derivative or RDU, the derivative of this is exponential x dx, and the integral of this, para makuha natin yung v ng integral nito, the integral is just x squared over 2. So wait, na-exchange natin to para di tayo ma-kilo mamaya. Okay, now if we take that in the form, or if we apply the formula, ano yun, roses are red, violets are blue, the integral of u dv is equal to uv minus integral of v du. Okay, so if we copy this form, or if we substitute this to this, that would give us I is equal to uv, so u exponential x times v, which is x squared over 2, minus integral of v x squared over 2 du exponential x dx, and we are stuck to this. So kung napansin ninyo, it became more complicated yung resulting integral natin, di ba? Mas complicated na siya dun sa given. Dito x lang, dito naging x squared na. So therefore, mali itong pag-assign natin. Okay? So let us now change these values here. Okay, now if ang u natin, kanina di ba exponential x, so let us try naman na ito yung u, ito yung dv. So if u is x, of course du will be dx, and if v is exponential, sorry, if if dv is exponential x dx, then we know that the integral of this, which is equal to v, is just exponential x. Okay? So therefore, following this formula, we'll have I is equal to uv minus integral of v exponential x du dx. So therefore, my answer na tayo. That's x exponential x minus the integral of this is just itself, then plus c. And that is our answer. Now let's proceed to another example. So we'll have to evaluate I, which is equal to integral of y ln y dy. So again, we'll use the formula that we know, integration by parts. So we know that roses are red, violets are blue. The integral of u dv is equal to uv minus integral of v du. Ayan. So, to get the integral of this, again, assign ulit tayo ng u at dv. So, by trial and error again, we'll assign u and we'll assign dv. So, if I begin assigning, let's say, paro kanina, tingnan natin, if u is equal to y and dv is ln y dy, then that would become du will just be dy, but pagdating dito, to get the value of v, or to get v, we need to integrate this, which is ulit, we don't have formula for ln y dy, right? So therefore, that will not be our substitutions. So, but if we let if we let u be equal to ln y and dv be y dy, then we'll have du, which is equal to the derivative of ln y is just dy over y. And if we get the integral of this to get v, then we'll have y squared over 2. Okay, now if we follow the formula for integration by parts, that would be uv, so uv, that would be y squared over 2 ln y minus v, integral of v du. So integral of v du. So that would be integral of vy squared over 2 and du, which is dy over y. So if we simplify this, that would be, we'll have I is equal to 1/2 y squared ln y minus, I'll factor out 1/2 and maka-cancel yung isang y, so that would become y dy. So therefore, I is equal to 1/2 y squared ln y minus 1/2 times integral of y dy, that's just y squared over 2 plus c. So therefore, our final answer is just 1/2 y squared ln y minus 1/4 y squared plus c. Then that is our answer. Very easy. Okay, suppose you have this integral I is equal to the secant cube of theta d theta. So we may answer this using transformation or trigonometric transformations. But how about if we answer this by integration by parts? Okay, so of course we need to substitute u and dv. So let us identify what would be our u and identify what would be our dv. Of course, dv should be the part of the integral that is easy to integrate. Okay? Or yung part ng integral na meron tayong formula to use. So what part of this integral ang meron tayong formula? Okay. So if we rewrite this as secant theta times secant squared theta d theta, we know that we have a formula for secant squared theta d theta. So therefore, pwede ito na yung gawin nating dv because we know the integral of this. That is just tangent, right? So u, I will assign secant theta as u and secant squared theta d theta as dv. So it follows that the derivative of u is just equal to secant theta tangent theta d theta. And the integral of this, meron tayong formula para dyan. So we have v is equal to the integral of secant squared theta. So that is just tangent theta. Okay, now to complete the formula, we have the integral of u dv that's equal to uv minus integral of v du. Okay, so let's start with, so therefore we have I that's equal to uv, so u secant theta v tangent theta minus the integral of v, which is tangent theta, times du, which is secant theta tangent theta d theta. Then if we simplify now, we'll have I is equal to secant theta tangent theta minus the integral of tangent squared theta secant theta d theta. Okay, so pwede na. Minus, we know that, how do we solve this? Pwede tayong mag-transformation ulit for tangent squared theta. So by transformation, we'll have integral of 1, baliktad. We have secant squared theta minus 1 times secant theta d theta. So we'll have I is equal to secant theta tangent theta minus integral of secant cube theta minus plus d theta plus integral of secant theta d theta. So I just distributed, so eto na distribute din, kaya na positive dito. Okay, and if you recall, eto siya, this is familiar. Bumalik lang tayo dito sa given. Ito yung hinahanap natin, di ba? Then nag-appear siya ulit dito. So that is not a problem. But anyway, the second part, which is integral of secant theta d theta, we already have a formula for this, or we memorized the formula for this. So wala ditong problema. Ito lang, lumabas ulit yung given, para siyang nag-loop. So if that's the case, then we'll just recognize that. We have minus, we know that this is our I. Ito. This is our I. So I'll just write here minus I plus the integral of this, which is ln secant theta plus tangent theta, then plus c. So of course, if this is minus I, transpose that to the other side, that would become plus I. So of I plus I, we have 2I, which is equal to secant theta tangent theta minus ln secant theta plus tangent theta plus c. So I now will be 1/2 secant theta tangent theta minus 1/2 ln secant theta plus tangent theta plus c. So this is our answer. Okay, let's try this next integral. So we'll call this I equal to the integral of exponential x sine x dx. So by integration by parts again, we know that the integral of u dv is equal to uv minus integral of v du. Now, let us identify what would be our u and what would be our dv. How about if we let u be sine x muna and dv be exponential x dx. Okay, so this is our u dv. So it follows that du is equal to cosine x and v is equal to the integral of exponential x dx is just exponential x. Okay, then we'll have what will happen here. So we'll have I is equal to uv, so uv exponential x sine x minus integral of v du. So v du. Sorry, may dx pa to dito. Yan, dx. Okay. I is equal to exponential x sine x. Then we have this. Wait ha. We have this second part with which kailangan ulit natin mag-integration by parts. So by parts again, if we let u be equal to, para consistent, cosine x and dv natin exponential x dx, then du will be negative sine x dx, then v is equal to exponential x. Ayan. So that would become, so agreein ko na lang ulit, minus, by integration by parts ulit, uv, yan, cosine x, minus integral of v du. So integral of v, which is exponential x du, which is negative sine x dx. Ayan. So we'll have I equal to exponential x sine x minus exponential x cosine x plus, then minus ulit. Ito, positive pero may negative ulit, so minus ulit. Minus integral of exponential x sine x, sine x dx. And ito yung hinahanap natin. This is I, right? Ito siya, I. So therefore, I is equal to exponential x sine x minus exponential x cosine x minus I. Then again, transpose this to the other side. This will become 2I is equal to, if I factor out exponential x, I'll have sine x minus cosine x plus c. Sorry, wala pang plus c. Dapat may plus c. So therefore, I is equal to 1/2 exponential x sine x minus cosine x plus c. That is our answer. So for you to practice, solve these 5 very easy problems as your assignment.